we talked about that another way to talk about the fundamental theorem of calculus, which is this equation we have up here, is that we can think about this giving us the amount of change of f of x from A to B, right? This is what we talked about last class. Amount of change of f of x from A to B is another thing. So along with like area under the curve, now we think about the integral from A to B being the amount of change of the original function from A to B. So this is where rates come together with amounts. Kind of a physicsy idea. I know that's going to give us a little bit of a groan, a few of us. Others are like, yes, this is what I love. But, so what this tells us in general in calculus is that if you integrate a rate, you get out an amount of something. So some very basic things before we like jump into any examples. So if you are integrating from 0 to 5 of a function that gives you the miles per hour, the answer that you are going to get back out is the miles themselves from 0 to 5, right? In other words, velocity integrates to give me position, right? A velocity of miles per hour integrates to give me the amount of miles. Okay? Oh, I just wrote that below there. Position. So another way of saying that, if you had something given to you in feet per second, that would integrate to give you feet, the amount of feet. Yes? So anytime you integrate a rate, it is going to give you an amount. All right, so that's going to be kind of like, so continuing to think about if I'm given a rate, I can integrate that to get an amount is going to help you with a lot of word problems, which is kind of where you're going to see this come in, rate in, rate out, all that good stuff. So it tells me here, C of t represents the cost per day. How do I know that that's a rate? Per. Yeah. Okay, this is my rate. To heat your house measured in dollars per day. And so knowing those kind of pieces of information is going to help you know what you're integrating to get at the end, right? Where t is measured in days and t equals 0 corresponds to January 1st, 1993. Oh, look, we're looking old stuff here. So interpret the meaning of the integral of 0 to 90 of c of t dt in the context of the problem. So we just said if you integrate this, which is a rate, what are you going to get back out? Okay, the cost, which is being measured in what? Dollars. So what is this telling me? This is saying the amount or the cost in dollars to do what?
That it changed.
Okay, that it changed, or that you had to pay, or that it cost to heat your house
for 90 days.
In the first 90 days of the year 1993, right? So this would give you, if you integrated back, how much it cost you, total cost, right? Because you're summing it up over the first 90 days, right? Now, what's the difference with what you see in part B?
It gives us an equation.
Yeah, we have something in addition to it. So we know what this represents now. The integral from 0 to 90 of c of t dt gives me my total cost over the first 90 days that it cost me to heat the house, okay? So what is that 1 over 90 minus 0 doing to this? It's dividing it by 90, which essentially is, in math, finding a what? How much it is per day. So, and we don't really know an exact cost per day because that would change, but in fact, we would call this the average cost per day to heat the house. Now, I'm going to give you a formula for average value, and then we're going to park there for a second so that this formula truly makes sense to you. Okay? So this formula right there, that is the average value formula that we're going to have. The average value of any function is going to be 1 over b minus a multiplied by the integral from a to b of f of x dx. Okay.
Not F prime.
We're saying f of x is the derivative, so it is the, yeah, it is f of x, because the average value of f of x, notice in this last question that we just answered, it's the average what? Cost per day. That is what C of t represents, the cost every day. It's the rate. So it is the average of the derivative itself, f of x. Now, just to talk about this in terms that this will make sense to you before, like, we're really only going to do an example with this, because this formula is not, like, hard to use at all. But here's what you need to understand, because you can be given stuff in a lot of different ways for this. We know a different way to find the average value of a function. What other formula gives us that? Yeah, slope, average rate of change. So why do we need this instead of average rate of change? Well, it just depends on what you're given. What kind of equation do you need to find average rate of change? What are you plugging it into? The original, right? Okay, so I'm going to come down here and write this for myself, and you might want to scribble on the side somewhere. We know how to find average rate of change. That is doing f of b minus f of a over b minus a, right? But that requires that you have the original function f of x, right? Now, I know in that average value formula, I wrote f of x, but let's just say that's a different way to find it with the derivative, right? So that's the formula, 1 over b minus a. We're integrating from a to b, f prime of x dx, right? Why do I have two different ways to find this? It gets kind of confusing to think about. I have average value this way, and then I have average rate of change. Well, let's think about what integrating does for us. If you actually did the math for this, what does f prime of x integrate to give you? F of x, and we are evaluating that on the interval what? A to b. What does that look like? F of b minus f of a, and that's being multiplied by this.
So it's like the division stuff.
It is. Doesn't that just go on top there? Isn't this actually my average rate of change formula? Here's the difference. That is the same as that. When do you use the average rate of change formula? When you are given the original. When do you use the average value formula? When you're given the derivative. And now this, write this down somewhere, because I guarantee you, I went, when I was doing your key to this homework, and I was like, I just went for the other way, and I went to find f of b minus f of a, and why did I do that instead? And she showed me this math on that, like, this is really what you are doing. It is the same thing. And I was like, oh my gosh, my head has just exploded. Like, this makes total sense. When you use which one. So if you get that down, when do you use which one in a word problem, it's going to make a whole lot more sense to you. If you're given the rate of change formula, you're going to use your average value formula. If you're given the original, the position one, you're going to use your average rate of change formula, and they're going to give you the same thing, okay? All right, so our only example that we're going to be doing with this is in question 2. If I want to find the average value of f of x equals sine of 2x over the interval, I see average value, and I go directly for this formula. So I say, okay, my average value is equal to 1 over b minus a. So what's b minus a for us? Pi over 2 minus 0. Integrated 0 to pi over 2 of what formula? Sine of 2x. dx. All right, so now I'm not going to do a whole lot with that front part. I am going to simplify it a little bit though, right? Pi over 2 minus 0 is just pi over 2. So then what do we do when it's a double fraction? Yeah, so let's make this 2 over pi. And then we integrate. We know how to integrate sine of 2x now without doing a,
1/2.
yeah,
Or -1.
negative 1/2 cosine. Thank you for not making me finish my sentence there. On the interval 0 to pi over 2. This is still f of b minus f of a.
Do we still do this subtraction?
Still do the subtraction. So we've got negative 1/2 cosine of, when I plug in pi over 2, what am I really finding the cosine of?
Wait.
Just pi, right?
Yeah.
Minus negative 1/2. What's this going to turn into? Plus 1/2 cosine at 0. All right, quick question. What is the cosine at pi? Negative 1. So that's positive 1/2. What is the cosine at 0? 1. So this is positive 1/2. So what's my final answer? 2 over pi. Okay. So now we have a formula to go directly to basically the average rate of change of the integral of that is what we're doing, okay? So right now, some of the stuff in your homework is just going to be practicing that formula. Some of it is going to be identifying in a word problem, here is my rate of change formula. Find the average value means to integrate that over that interval, okay? So